2015, the first R&D Hangout of the year for e-NABLE. So, Peregrine, what time zone are you in these days? What time zone are you in?
I guess it's I'm in Virginia. I don't
Eastern.
Eastern, right? That one.
Okay.
I'm still all disoriented from all the traveling.
Understood. I added about 8 gigs of memory to my computer here, and it makes a huge difference. Much more reliable. Did they get rid of the plugin for the Google Drive?
I don't know what you mean.
Where? You mean the one? Oh yeah. When it comes to Hangouts, I think they did.
Yeah, that's what I thought.
Yeah, I saw a message that it was going to go away. I forget how long ago, but I did see a message about that one time when I was doing a Hangout.
But what you can do, I think, is paste a link to a document,
Right.
and it will show up in the sidebar.
Yeah.
We'll do that.
Oh yeah, it's not there anymore. Where'd it go? Not fair.
Yeah, I kind of liked it because it immediately posted everything so that people knew where.
I saw something in the group about a worm drive. Are you the one that started that, or what was that pulley thing that you showed off a while back?
That was a precursor to the Whippletree pulls. It wasn't for tensioning elastic.
Okay. Yeah, I don't know what a worm drive is, but somebody was mentioning it, and I don't know why I thought you were the one who was working on it.
Yeah, I don't think we ever had anything complex like that for tensioning the elastic. I think that's kind of adding a lot of extra complexity that's not horribly necessary. Because no reasonably sized mechanism is going to let you adjust elastic enough for it to have a real difference. I mean, what, 20 millimeters of travel on the length of the elastic isn't going to be a huge change in the tension. You just kind of have to tie the knot at the right place.
Yeah, you would only want to use the worm drive on the pull cables.
Yeah.
That's interesting that you should mention the elastics there. Because over here we've actually stopped using them.
Yeah, just relying on the Bowden principle with...
Yep, all that's in here is 5 cables, and they're... I mean, you can see it's working pretty well.
Yeah.
Yeah, I saw that in the video.
Yeah, I saw that too. It was great.
Yeah, and we've... I mean, it's...
the stiffness of the cable? You said in the video that it was because of the stiffness of the cable?
Yeah, well, the cable, it's, I'm not sure exactly what it is, but it's some kind of nylon... It's trimmer wire, so it's some kind of nylon cable, and it's just stiff enough that it holds in place relatively well. It doesn't bunch up like some kind of braided line. and it can push the fingers open.
Yeah, you get a little push out of it.
Yeah.
Yeah.
And I added, I'm not sure if you can see there, a few copper rings to just kind of hold the cables in place a bit more, but it works without them even. I actually started taking the elastics out of this to replace them, and then started playing with it before I put the elastics back in and decided not to do it, not to continue with that, but just leave them out. And I'm actually using it a lot more now. It's a lot less tiring to use.
Mm-hmm.
Yeah, it seems to me with just a very small amount of provision, you could do what Peregrine has done here. You get some push out of your cable, and if you just pay attention to how you house your cable, you can certainly obtain quite a bit of push out of it. Apparently.
Yeah, well, you need to use a relatively thick monofilament cable.
Correct. Correct.
Something braided will just bunch up.
Right.
Some of the really lightweight fishing line will still bunch up.
Mm-hmm.
But somewhere around here.
I'm working with some young, a really sharp young kid down in Texas who is reinventing my original hand, and I am having him use nickel titanium wire as a return spring. So
Okay.
I'll let you know how that comes out.
Yeah, that's
Wait, so nitinol?
Pardon me?
Nitinol, like heat-shaped memory stuff, or?
Yeah. I've got a couple different sizes. I have a customer, Tulsa Dental Supply, who's actually a world leader in endodontic products, and I do a lot of tooling and test equipment for them, and they gave me some of this wire. I have it in 045 and 030, and it's really wicked stuff. But anyway, I'm going to be using this as a return spring, and I'll report to you about the progress and the success of that.
Okay. It's interesting because one of the things that we're trying to do with this is actually find a cable that is somewhat less stiff that will still do this. Because right now the main issue with it is that it's stiff enough to push the fingers open, but it's also a little too stiff to go around corners very well.
Right.
Mm-hmm.
So it'll grip something and it'll go mostly around the corners, but then as you apply more pressure, you can still apply more pressure without the fingers moving because the cable is going around the corners at a sharper angle. And
Have you ever tried using that real thin sleeve material that they use in bicycle cables? It's a real thin nylon tubing that might make it slip through a little bit better.
We haven't tried that, no.
I have some I can send you in several different sizes, but you can get it at any bike shop.
Okay.
Big Master sells it, but I'd be glad to send you some.
You could probably find some, I guess.
Yeah. There's a local bike shop. Okay.
Hey, Peter.
Joel.
So,
Hey.
Or you can also get it at your local plastic supply dealer.
Yeah. You can also probably try, I guess we've done this before and there's some sort of issue with it. Too stiff, I think.
Yeah,
that might have been with elastics. No, not that stuff. We never
I know what
tried
you
that
mean. You have
before,
to find stuff that's real thin wall, and it's hard to find. But I'll look on McMaster tomorrow and see how flexible of sleeve I can find.
mhm.
No, I was talking.
For in here that wasn't going to have so much issue with the going around curves?
Well, I mean, like this stuff.
Yeah.
Okay. Well, I got some nylon monofilament here. It's this is actually a fishing leader, so it's fairly low memory stuff. And for $10, you can get 100 yards of. I got some 1.4 millimeter, which is pretty nice. I think even for smaller builds, and I'd probably go up to a 1.6 or a 1.8 for large builds. I think we decided that the 2mm was just too thick, that it was going to be too rigid, to go around the curves like you'd want it to.
Yeah, I was about to suggest fishing leaders, and potentially if you could find some really thin versions of those plastic-coated wire leaders.
I've tried
work.
those. Well, okay. I tried them a while back, and they actually failed back here on the tensioner, because I'm still using the set screw tensioners, and I split the tensioner in half trying to install those, because you cannot install them. You can't screw this down tight enough that those don't slide out.
Yeah.
They're so thick. So
Makes
low.
sense.
You might want, on those set screws on your tensioner, Peregrine, you might want to take your set screws and put them on an Allen wrench and take it to a belt sander or a grinder and grind that cup off the front so that it's kind of smooth and rounded on the front of your set screw.
So they're
you'll get better clamping and less cutting.
That's an idea. We're also, because this is all the way up here, I've got all this arm here. We're talking about extending this down and then having maybe 2, maybe even 3 set screws per cable.
Yes.
To get that much
you can also put a little piece of plastic underneath your set screw, or you can print a little saddle to go behind your set screw that will fit the diameter of the cable you're clamping onto.
Okay.
It would be basically just a little cylinder with a radius cut out in the end of it.
Just something to cushion between the set screw and the cable.
Yes, sir. Yes, sir. I'd be glad to make those for you if you'd like.
You can print those.
We've got 4 printers here, so I think we can...
Okay.
Yeah, and along the same lines, you might try putting small divots underneath the cable so the set screws are pushing them down into a space instead of just against a flat surface.
There's an idea.
Yeah. What on earth was I about to say? Oh, right. This is silly and probably not wonderfully productive, but for your very custom hand, you might try using a bit of heat and some pressure to compress those nylons down a bit so that they're thinner in this axis, basically.
Oh, make them
more
ribbon-like?
So you can try and keep the same cross-sectional area so that you have the same tensile strength, but they'll be a little bit more flexible in this direction.
There is an idea, yeah, okay.
That's pretty clever.
I like that idea, yeah.
Wow, you're smarter than you look.
The heat might do some magical stuff to it and make it like glassy or God knows what, though. I don't think nylon does.
On this same subject, you might want to try double back your material through the same hole. So now you're clamping on 2 pieces of material instead of 1. But you would have to have a big enough hole in there to do that.
Yeah, I think that might add too much stiffness to the system.
Right. I noticed that
a lot of the hand designs have grooves that the tendons go along. I wonder if you put Velcro that you could tension down over the top of the grooves, if it would hold the wires in the grooves, and if that would give it more of that Bowden effect.
Yeah, well, we were thinking of either using some kind of tube or even just closing this whole thing off to do that, just in case all of this. Because back here, there's actually not very much room for the cables to. Yeah, there's not much room for them to buckle up. It's all up here that happens.
Right.
And when you were complaining about buckling with thinner materials, was that happening back there or in the actual fingers?
With thinner materials, it happens up here a bit more. Though depending on how thin the material is, it would also happen back here.
Yeah, so I mean, if you redesign the non-finger bits, you can probably get away with a good bit thinner material for the part where you actually want that stiffness.
Yeah, oh yeah, some good... this is not actually designed to run on Bowden. I just pulled out the elastics and found that it worked. It's kind of a miracle that it did.
The other nice thing about where you're indicating the back of the palm is that length of plastic doesn't change, so the tubes would be fine. They wouldn't bunch up.
Well, here's another idea. You could just house your pull cable in a semi-rigid plastic sleeve just to give it body in the open areas, keep it from buckling, to give you a better push.
So, so like putting just a tube.
Like a bike cable, yeah.
Yeah, that was one of the ideas. One things we're considering.
Alex Thomas did a lot of research on push-pull, and he swears by nickel titanium wires.
Okay.
And he sent me some, and I'd be glad to send some of it to you. I sent some to Peregrine and a number of different people. I don't know if I sent some to you, Peter.
Yeah, I got some.
But I sent some to a couple different people. But anyway, my point is that I've got some really cool nickel titanium wire that Alex sent me, and I'd be glad to send it to you to experiment with push-pull.
Okay, well, if we've got some,
I've got a bit.
then
Yeah. My feeling with it is that I think it's going to be too rigid. Well, actually, what you sent me was you said there was some thinner stuff.
I have some. Did I ever send you that 030 titanium wire?
I think no. I think
Okay, I'll do that right away. I'll do that tomorrow. But I'll also send you some of the ultra thin nickel titanium leader wire that I bought, and some stuff that Alex sent me. I'll send you some of that you can play with.
okay,
It's real thin.
the stuff we've got here, it seems like it's really good, but it's a bit on the stiff side.
Well, I sent that to you intending to make springs out of it, not really a push-pull cable.
Okay.
But I have some material that I will send you that will be better for that application.
But yeah, some thinner stuff with that would probably.
Yeah.
I think that would do the trick.
Yeah. Yeah. Okay.
Yeah, it might not be. It might be trending away from the accessible and anyone can do it with a trip to Lowe's, but I think it could work very well.
Right. I think the most complicated part that I see about using nickel titanium as a pull cable is how to crimp the ends on it. I haven't had much success with that.
Okay.
Yeah.
Well, if you haven't had much success, considering what kind of stuff you can do,
Well, I didn't really have the right fittings, and I'm not really knowledgeable. I didn't do enough research to really understand. I tried to tie some of the stuff in some knots using the directions they gave me, and I didn't have much success, but I'm sure Peter's a lot smarter than me in that regard.
Oh. Wow.
For Nidinal, you probably just want to...
He's been down this road a little farther than I have, but I'll send you what I got, and we'll go from there.
Great, yeah.
All right.
Play with it.
Okay, so one last note on that. You might try just soldering little beads on or something. It's because I think Nidinal is one of the metals that can actually do chemically bonded soldering so that it's strong and not ridiculously weak. But I'm sure you can figure something out there. Peregrine, did you see the post or the video of the skin stretch feedback?
I don't think I did, no.
It's on the community. Let me find that. It's they had little sticky pads on, I want to say it was this part of someone's arm that were attached to the fingers of a myoelectric prosthesis, actually. So the skin would get pulled up or down slightly based on the position of the fingers. And they, the users were much more repeatably using their devices, if that makes sense. They were, they could position it where they wanted to without looking at it.
Okay.
Incoming link in just a second.
Yeah.
No, I got it. Oh.
Yeah.
Hey, I'm going to be heading out of here. John, Joel, I might be going down to Dallas to meet some young kids that I'm working on this hand with who are down in Houston. I'm going to probably meet them in a makerspace somewhere to help them assemble.
When would that be, Bob?
It's probably going to be in another 2 or 3 weeks, I'm guessing. I just want to check in with you and see if I need to get any clearance from you or approval, because I've been in trouble for this before.
Yeah, I really appreciate it. There's going to be a lot of activity in Houston around the 26th, I think. And is Houston where you're going?
Houston is where they are. That's about 11 hours for me. And so I'm hoping to meet them. I actually made a post today to find a tool maker in Dallas that will let me come into his shop, or just meet at a maker space somewhere. And he can bring his dad and his teacher and whoever.
So listen, I'd like to talk to you about that, because we've got an event happening around that time anyway. It would be good to have you there, and that would also address the more general issue. Okay,
great. We'll touch base about it. Cool. Thank you so much for your time. And I'm going to leave you, but I won't bore you guys. But I'm just floored by this amazing network that you have built, John. We have people helping each other. I don't know how you sleep at night. It's just ridiculous, this monster that you have built. And God bless you, and thank you for everything.
Well, Happy New Year to you too, Bob.
Goodbye, sir.
Goodbye. So, Adam Arabian. Happy
Dressed
New Year.
awful fancy. How you doing?
Greetings to you as well.
When Adam shows up, he probably has something to show and tell. Can we find out what it is today?
Unfortunately, nothing new. I'm waiting to find out from my student. We've got a latch for the Falcon that we're almost ready to test. He had one problem with it. I'm waiting for my student to let me know it's fixed. But nothing new today. Just hoping to check in and see how people are doing and hear what the buzz is.
Cool. Latch to lock position?
Correct.
Fun stuff. I'm glad someone's finally testing that out. It seems...
Well, it's not working yet, so
yeah, but they're building it. That's 2 steps further than we'd been before.
We have a question on the Q&A from Jeff Aronstone. He asks, what about the FlexiHand and WaterJet cut urethane dog bones?
That was addressed to Bob Roth. He offered, I don't know if it was for whoever asked the question specifically, but he offered to WaterJet cut the little kind of figure-8 shaped parts that you use in the FlexiHand out of sheet urethane, which we tried this summer with some urethane that was just way too stiff. But he says he has some 30A or 40A stuff, which is kind of the perfect range for that from what we saw with silicone. The only caveat is that urethane might have a smaller, I guess, percent stretch before failure is the statistic that matters. So it might tear more easily than some of the silicones we were using, but I don't know if that's the case. So definitely worth trying. I think Bob's already off to fire that off on his machines. It'll happen in a few weeks, I guess.
Could somebody clarify something for me that's kind of related? I saw something about, well, I heard, I guess, somebody offering to do resin molds or something like that about the dog bones. Was that silicone also, or was that resin?
Yeah, that's silicone. The
as opposed to cutting it.
As opposed to printing it or cutting it. So when Gyrobot, or Steve Wood, designed it, he was doing printed NinjaFlex joints, which are a little stiffer than would be ideal, I think. And then at Amory this summer, most of Dale Price and a little bit of me were printing molds in the same shape and then pouring various smooth-on products into them. And some of those products absolutely don't come out of printed molds. They bond to printed plastic, and Like, they bond more strongly than the plastic does to itself. You can't do that. But some of them came out very easily and were just about the right stiffness and durability for what we were doing. So Smooth-On 30A Dragon Skin is the material that works well for dog bones. And you can do whatever curing speed you want, but a slower one's probably ideal because you can let it sit to get bubbles out, which will make it tougher.
Okay, good to know.
Yeah.
Did we want to watch that YouTube video in line to give Peregrine a sense of what the sensory feedback thing is about?
I took a bit of a look at it there.
Okay.
Yeah, I think he just needs the gist of it. So how much do you think feedback of that sort would help for these body-driven devices where you've already got clumsy feedback in the form of your proprioception of whatever's driving it?
Let's see. You're talking for people who don't have a wrist?
Well, no. For people who don't have a wrist, it would, I think, obviously be pretty valuable. But for people who do, particularly with the Whipple tree now, you'd be able to feel, if you did separate pads for this, you'd be able to feel the position of individual fingers through this skin stretch mechanism. So you'd be able to tell if you were reaching under your desk and grabbing something, you'd be able to tell you've grabbed a cylindrical object because the pinky and pointer are bending more than the ring and middle.
Yeah, I think that would be pretty useful. I've actually found that after enough using this, I have a very faint sensation of that. Doing this feels different from doing this, actually.
Yeah, I guess you can probably feel the sort of torque on your on the hand. Yeah.
If there's not much force, then I can't. But if I'm putting a lot of force on there, then I can kind of feel the difference between the different fingers. And
yeah, it makes sense.
So I think it would be useful, but we've already got some of that built in. And that is with
and you've got constant tension on yours, huh?
Yeah.
Yeah. So
I've just got the same amount of tension all across the board. So any slight change would be noticeable. I think that with a much more adaptive kind of grip like that, that might be more necessary if you're going to have the same kind of sensation.
Yeah. Adam is he's busy chatting. Yeah. Okay. Wanted his opinion on that, but yeah. Any ideas how to build it or something then?
I'm sorry, I was distracted for the moment.
No worries.
Didn't mean to shout at you. Have you looked at the skin stretch feedback device in that YouTube video?
I haven't, no. Sorry. Is that the one that's linked up above?
Yeah, yep.
No, I haven't. Sorry, I missed that link. I'll take a look at it.
Okay. So the other maybe unfun part of that idea. Oh, see you, John. That was quick. No goodbyes. Oh well. The other maybe unfun part of that idea is we definitely don't want them to be attaching stickers every time they put the hand on. That just sucks. Right. I think that the way, going all the way back to your Intel talk, I think the way you can just pop your hand on and off is really nice and something that we should maintain.
It's actually especially just learning to use it.
Yeah.
Because there's a lot of cases where this is more helpful, but then this is, you really don't know how to do this one yet. So you need to be able to switch back and forth.
Sorry, actually that was something I'd seen. Sorry, Nick. So I haven't. So I've done a bunch of work with Vibrotactile rather than I haven't done anything like this, and it looks like their feedback loop is their. If you look at their data, just that quick slide, their data is real similar to what Vibrotactile is. Actually, the same error bars and everything like that, pretty much. But pretty much what we found with the Vibrotactile stuff is it provided a little bit of value. But for the most part, people who use those devices, they have lots of other inputs that they can work from. The sound of the motors is really valuable to them. and then visual. So there's already a lot of feedback, and we found people were kind of starting to filter it out pretty quick.
And in the specific context of body-driven ones where the fingers can close different amounts, do you see any value?
Depends on how we're doing the body-driven stuff. Let me think about that for a second.
Yeah. Okay.
Because normally you don't put electronics on body-driven stuff, and so
yeah. Well, the advantage I was seeing with this is that it wouldn't be electronic. You could just use the same cable pulling mechanism to pull some little silicone pads back and forth.
But you're gonna have to put like multiple different pads on each time every day.
Well, no. My thinking was soft silicone that just presses against it. That's built into the gauntlet, so you're not actually sticking anything. It's just
the silicone pads on rails with springs.
Yeah, I think Trouble came up with that actually.
Yeah, I'll say why not. It's an interesting idea. It's one of those things where you really, how people use it is going to be a big question. But it seems intriguing to me. I haven't seen it done. I mean, the Whippletree thing, the adaptive grasp for a body-powered prosthesis, is in and of itself kind of interesting. And I think I've seen one design like that before. So it's kind of cool, and so being able to add that in as a unique feature, I don't know. Certainly worth investigating.
Yeah, that actually sounds fun enough that I may have to take time on the lab printer to try that out. Or I guess I do have a printer here in California.
Another idea, if it's just the sensation of motion, you can maybe put wheels, like the touch wheels that spin as you roll it along. You could probably feel how far up your wrist the pad is instead of a pad with a wheel, and that would also make it less needing of tension, less needing of pressure against your wrist. And
so that's a trade-off there.
How much differential are we talking? I mean, I guess I'm thinking about, for a different grasp configuration.
Yeah,
how much are we really talking differential lengths? I can see it possibly working with shear pads because you're going to get sort of you're going to get basically that kind of shear. This pad is going to be ahead of that pad a little bit. But even so, I'm just not sure how much effective length difference you're really going to get. I mean, if you put two fingers on your skin and you just kind of wiggle it, half an inch one way or the other, you can feel it a little bit, but is that enough to provide a definitive experience for quality of grasp? But that's where it becomes science rather than playing around, and that's what's cool. So.
Yeah. Well, so when they're all closing, I don't think so. I mean, when they're all moving in parallel, I can't feel that much at all. I don't think I'd be able to tell the difference between half closed and fully closed from that. But I do think that it would do a pretty good job if you put them right next to each other of conveying which finger is more closed.
Right. But the real question is, how does that change how somebody uses a device? That's what you got to think about. And so, do I really, as a user, care that this finger is closed more than this finger? Yes, it's more data, but do I care? And so, but that's the kind of thing that it's really hard to know until you build. I mean, you can come up with arguments on either side. That's the kind of thing. You build one, you give it to somebody, let them wear it for a week and say, yeah, it made a difference because of X, Y, and Z, or, you know what, after a while I just totally ignored it and it didn't matter. So.
Sounds like someone should try it.
Yeah.
And by someone, you, right?
I haven't built any hands in the last 6 months or so. I've been busy with other 3D printing stuff in Hobbs Lab. I'm really not going to be any more available next semester. I might attempt this at the beginning of the semester when things are still slow. But if I don't get it done in the next month or so, I probably won't for a long time.
Yeah, I'll be honest. I'm kind of this quarter is pretty bad for me, so I'm actually on light duty for a lot of this stuff too, which is unfortunate, and as are a bunch of my students. So it's I'm not going to be able to make a lot of progress either. But hey, there's always summer. So
Yeah. And it's still an idea that's in the brainstorming process. So.
So just out of curiosity, so I don't think anybody on right now was one of the gluttons for punishment who are interested in printing out one of the Falcon hands. So
Not yet.
so, but I'm still interested in seeing how that pans out, and I'll keep everybody in the loop as we get feedback on it.
Okay.
I like that we somehow ended up with a bird theme. We
Yeah,
have Raptor, Talon, and Falcon right now.
Well, that's our university mascot, and so I built on the Talon thing for that. It was a baby step. So, but yeah. So anyway, it's there's some interesting stuff, and there's some stuff that's not working great, but there's some stuff I'd really like some feedback on. So anybody who's interested, let me know.
You have one around here?
Around here, well, I'm not
around.
You're Bay Area, right?
I mean, around you that you could hold in front of the camera.
Yeah, actually, I haven't taken that. So, yeah, it's this guy. I showed the video of it before, so I've got the positionable thumb. We're using the. I mean, you guys have my. Say again?
Can you hold it up higher, like near your face?
Yep. Sorry.
Thank you.
That's the positionable thumb I hadn't seen before. That's a very smart way to do that. And that's two position that like clicks into place somehow? It's not.
Yeah, it's got a little. You probably can't see it. Well, yeah, there's no way to see it, but there's a little bump on the thumb rotator that just snaps into place. Now, actually, on this one, because it's one of the challenges I'm having is it actually shears off a little bit. And so this one I lost, and so this one actually doesn't have that, and it still actually stays in place pretty well. So I don't actually think that's important, and it gives you the ability to position electively at any point in that rotation. I can't guarantee that will always work, but it's working on its own, and so that's something we're going to investigate. So, but we're using the cable crimps on the back, and then one of the things I'm working on, this was a necessity for our engineering, but so the clamping mechanism that we're working on, hang on a second, the clamping mechanism that we're working on fits right back here. I don't know if can you guys see what I'm doing right now?
Yeah.
Yeah. Okay. So the clamping mechanism is a slide clamp that fits back here, and it just engages those cables on the palm side. So we should be getting that out shortly, I think, as a trial run. But in order to make that happen, we had to go with this. We were going with this modular palm cover. The modular palm cover is not working great. I haven't come up with a good way of securing it down because I want it to be also removable. So if you need to fix something, because that's kind of the whole thing about this is we wanted it to be. You break a finger, great, you just take the finger out, and then you thread the cord back through, you use a coin to re-crimp it back down, and then you just snap your finger back in, and you're back in business, right?
Nice
and
joint
so
design,
when you
by the
print
way.
one of these things, the idea is you aren't just printing one, you're printing like a hand plus 3 extra fingers. All the fingers are the same size because our palm is... because we put the finger geometry into the palm positions.
Yeah.
So all the fingers are a different size. So anyway, we wanted to have this modular palm cover so that it could also be repaired, but I just haven't figured out the way of securing it down. That's anyway. It won't preclude people from testing it, but it's also enabled us to be able to test out the locking mechanism. Another thing we've been testing that I got to work on a little bit more. Someone was recommending a bushing system for the thumb for friction. I don't know that it's required, but one thing we tried, I don't remember when this conversation was, it was sometime probably 2 or 3 months back, but they recommended using a Bic pen barrel for basically low friction bushing. So we actually tried replacing. If you can see our fingers, our fingers snap on over these shafts that we printed in. So we changed the size of that shaft so you could snap a Bic pen barrel over it. So far, it doesn't seem to have made a huge difference, but we're going to keep experimenting with that too to see whether we can reduce friction by doing that. So it doesn't seem to have mattered much, but maybe it will in the long run. Anyway, that's what we're working on. But all good stuff, all just kind of trial runs though, and see where they end up.
Yeah. And one quick question: are those fingers just linearly offset, or are they also splayed out slightly?
They are splayed out. So can you? Let's see.
Yeah. Okay.
Yeah. So they kind of separate from each other. I don't like my finger geometry. I'm seriously considering just stealing the. If it weren't in some bizarre format, I would just steal the fingers for the flexi hand. I think they're very attractive. So one of the next steps I'm going to do on this, I'm actually going to try flexiizing this. So instead of using the rubber band elastics, I'm going to try replacing those with the flexi, hourglasses. See what that does. Anyway, yeah.
Yeah. Or I guess you missed the earlier conversation about push-pull on Peregrine's hand.
Yeah.
It seems like it could fit well.
We really struggled with push-pull. We worked on it a lot last summer, and overall what we found was that we really had a hard time finding a balance, and maybe string trimmer line is it. We were using ultra-fine, like really good quality shifter cables for bikes, which is really small diameter stuff. But just the flexion of it just had so much resistance to flexing that it seemed for us, it offset any advantages, which it doesn't sound like that's what's happening for Peregrine. It was offsetting any advantages of removing the elastics. But it sounds like you guys have that problem licked. I haven't looked at how, but I haven't. But it sounds like you guys have solved that problem.
Yeah, well, I mean, the hand I'm wearing right now, there are no elastics in this.
Right, exactly.
The thing that we found is that the cables don't have to be super rigid for them to for the push-pull to work.
Yeah.
Like the cables here, you can kind of see they're buckling up a little bit.
Right.
And even with that, they're...
Well, the extension is not there's not load on the extension side, right? And so when you need the load, that's on your flexion side, and so that would make a certain amount of sense. So, no, I mean, I'm definitely interested in seeing how that pans out. I think that's a pretty cool idea. I hope that's got some good legs on it.
Yeah, we've got some other line we want to test out. But yeah, the thing is that this actually wasn't designed to take. It was designed to have elastics in it. It wasn't designed to run without them.
Right.
But I just took the elastics out and started playing with it, and it seemed to work all right, so I left them out. And so far, the biggest advantage I've found is that I can wear this for a lot longer.
Yeah.
The elastics are kind of tiring to wear and use.
Well, and I find the elastics are. I mean, we spend a lot of time trying to engineer around these rubber bands because I hate the manufacturing side of the elastics. And my concern was if a finger broke in the field, it was an unsupportable component of the system. And so we spent a lot of time engineering around these rubber bands so that we could get. So that was the way we could come up with to solve that problem. But what you're proposing is a similarly advantageous solution with fewer components, less to source, and more reliable. So it's attractive. So I don't know. Maybe I'll try that before I flexiize it.
Alright. I would definitely recommend it, because it's worked out really well so far.
So basically all you did your standard build, and you just increased the size of the holes, and you put in string trimmer line.
The holes aren't actually that much bigger.
Okay.
I mean, it's kind of a big hand.
Right.
but the holes aren't especially increased. We just have the cables, instead of being braided, they're monofilament.
Right.
So they don't compress at all.
And I think you guys said they were pretty high tests, like 300-pound or something like that, monofilament or something.
Well,
Yeah, that sounds about right.
do we actually? Well, that's what we're going to be trying some.
Okay.
Well, now, so that's pretty similar to like 3D printer filament in its diameter, but it is nylon, and it's kind of a low memory nylon. The stuff for trimmer line. If you take monofilament fishing line at 1.8 millimeters, which is about what that is, that would be a 300-pound test.
Okay. Yeah, that's yeah. I mean, the printer line you wouldn't want to use; it'd be too brittle. But yeah, I'll try something like that out. That's a good idea. I'm intrigued. How did you secure it on the end of the finger? I apologize. I missed all the good stuff when you guys were talking about this before.
Oh, it's we just take a lighter to it and make a little bead on the end.
Okay. Yeah, that's what I've been doing on ours too.
And just kind of yank it through enough.
Yeah.
And you could put something on the tips there, or try to fill it with something to stop them, because they'll occasionally pop through, and it's kind of amusing.
Yeah.
That's about it. And you get the sort of like alien mouth within a mouth, except it's a finger within a finger effect. But it's you just kind of close it and pull on it, and it all pops into place.
Okay. Are you doing something back there?
Testing it to see if it works on that.
Okay. Yeah, that's the stuff. That's what we were doing before with the when we were using the smaller monofilament. So, all right, I'll give that a shot. That'll probably be the next thing. I'm not excited about using. I mean, I shouldn't say I'm not unexcited about using the FlexiHand stuff. I consider the FlexiHands to still be a little untested, just material-wise and stuff like that. So I'm more intrigued on building with the direction you're going. So maybe I'll give that a shot next. And I'm pleased to hear. I think it also solves a lot of them. Go ahead.
Oh, I think how are you attaching people to the back part here? So
we've got crimp terminals. So basically, if you think about kind of how IKEA furniture works, so basically the string threads in, and it threads through a little hole, and it just twists and crimps.
Okay.
So it probably would not work for the diameter of stuff you guys are using, so I'd probably want to do something like what you're doing. But I would be concerned about exactly the problems you're having, that it would tend to split. You know, 3D printed stuff is not well suited to what you're proposing to do.
That is the biggest issue with it so far.
Yeah. So have you put a nut on the back side of that?
We have not tried that.
So if you put a nut, it'll basically kind of. I mean, basically, you're putting in sort of a bearing plate by threading it through a nut rather than trying to tap it direct. You're tapping it into the plastic, basically, right?
Yeah. Yeah. Oh, everything, all the.
So what I would do is I would print a hex. Go ahead, sorry.
Yeah, all the metal hardware on this, with the exception of the joint here.
Yeah.
It all taps into the plastic.
Okay.
Screws
yeah,
running
I would try printing just a hex void on the back side of that you can thread a nut through, because what'll happen is it'll basically that's what's going to take care of that splitting. That'll probably work, depending on the size of the nut. But yeah, that's the only thing I'd be worried about. But I like that because that solves the same problem that I was concerned about. That if you want to be able to field replace the finger, which I want to be able to do, you know, as quick a turn on that as possible. Your solution is also effective, I think.
Yeah, I mean, I still, if I want to replace a finger, I go back and actually at this point the only thing I need is a hex key to pop this stuff
right.
up.
Yeah, it looks pretty straightforward. I mean, you gotta see. Are you using? So you've got the that's the printed pin bar? Okay.
Yeah, printed pins.
Yeah.
And through there, and they. Yeah, and they're relatively easy to take out and put back in.
So I'm surprised the ones that we've made have been incredibly noisy, which was why one of the reasons also we went with what we were doing. Yours is surprisingly quiet. I don't know if that's build quality or tolerancing or what, but all the hands we've printed, most of the ones you see videos of, they're noisy as all get out.
I think that has a lot to do with the tolerance, like how much space is in there.
Yeah.
I have a couple of Raptors, and they are ridiculously noisy.
Yeah.
That's the amount of tolerance that was built into them.
Right. The reloaded seem better, or?
I have not tried the reloaded.
Okay.
Mine are all classic.
Okay.
Not even the most recent classic, actually.
So why is yours quieter?
This one is... Well, there's actually not as much space in there.
Okay.
So they don't rattle around.
Okay.
I'm guess is that what you're thinking of with the
I think that's probably what it is.
It's
yeah.
the rattle? Okay.
Yeah. So I mean, what we were doing, instead of using the printed pins, we're using filament pins as our hinges, and then we've got the snap-on bars, and that makes everything pretty tight, and so it's, you know, effectively silent, which is another thing we're going for. If you solve that problem another way, that's great. But
yeah, well, it's not completely silent.
Yeah.
But most of the noise is from, like, it's when the fingers bump against each other, mostly with that grip.
Gotcha.
There's a little bit of squeaking, and I'm still not entirely sure where it is.
Gotcha.
I have searched for it. But I also use a bit of, whenever I replace the fingers, I throw a little beeswax in here.
Yeah.
And that pretty much makes it pretty much silent. That extra little bit of friction, or frictionless tolerance reducing stuff, basically.
So, anyway, that's cool. Well, I may steal some of your good ideas if that's all right.
Oh, stealing is encouraged.
Yeah, I don't know how much time. I just made to help me out this quarter, so maybe that'll be a direction I send her.
Also, you mentioned that you're having trouble attaching the little back plate there.
Yeah.
Have you? First, how easy do you want it to be to remove that?
Doesn't have to be easy. Just I don't want it to be tooled. So I've tried pins and I've tried snap. You know, basically snap retainers. Neither of those are working real well. They tend to break too easily.
Okay, because right now, I mean, this is a different piece from this.
Yeah.
We have a couple of screws that just bite into the plastic.
Really?
Yeah, and it's solid. I've never had an issue with that.
I don't mind that because the only thing that you actually need for this particular palm cover design. Now, the idea is that anybody can design their own palm cover. You know, you give them the template and they can put the Wolverine palm cover on or whatever. So theirs may be more difficult, but the only thing you would need to fix would be if the thumb broke. You would need to be able to get in there, and so it would be less likely, I guess. You know, so you want to be able to do it, but
well, it's pretty easy. Just get out a screwdriver and you can pull this off in a minute or two.
Yeah. Yeah, I mean, my goal would be, you know, kind of my back of the envelope goal is to have basically an Altoids tin repair kit. So if that includes a short little stubby screwdriver, that's not a big deal. You know, I think you guys know, I mean, I'm working with those folks in Syria, and so what I want to be able to do is print, deliver, and have it able to be maintained by the user in a fairly austere environment. So, you know, and it needs to be affordable by a person who doesn't have, you know, who is on their own, basically. So basically all needs to be workable single-handed.
Okay.
With no Lowe's or Home Depot available.
Yeah, exactly. So, but the kind of stuff you're talking about is totally within the scope of that, I think.
Yeah, I can take this whole thing apart with a screwdriver, 2 different size hex keys, and a well, right now you would have a wrench on there, though we're going to take that out of the equation pretty quickly.
Yeah. You know, it occurs to me I'm a little worried about the ability to use the Bowden cable, the push-pull cables on this thumb, because we have to go around a fairly tight radius.
Yeah.
Yeah, well,
That's going to present a problem.
That's what we're doing here. It's maybe not as tight as what you're talking about.
Yeah, this goes to when it's in this position, when it's in the cylindrical grip position, it's 180 degrees.
There, yeah.
So this is 90 degrees, or let's see, yeah, 90 degrees that it wraps around, and this is 180. And if you look at the actual part, it's a torturous path. That might present a problem. I'll have to think about that.
Yeah, it would probably have to stay spring-loaded, I'd say. But I need to run. I just wanted to add on the topic of filament for the bearing surfaces. I did that in place of the M3. I used 3mm filament in place of the M3 screws on some really old design for John Long. And the awesome side effect of that is that with either filament friction welding in a handheld drill, like I forget who was talking about, or just a soldering iron.
Yeah, that's what we use.
You can attach those in place really nicely with a little bit of melting, and yeah, nice. I don't even see
that's what we're going to.
I don't even see the attachment there. So that's a nice trick to be able to pull. You end up with a very smooth outer surface.
It gives you're able to work in much tighter spaces. Yeah, you don't have to have the heads of everything sticking out. So.
Yeah, and you don't need $15 baggies of Chicago screws. Anyways, gotta run.
Oh,
cheers.
Thanks for joining us, Nick.
Yeah, but the what we were finding, I mean, the heads for the printed snap pin stuff takes up geometric space. And so that was by using the melted filament hinges, you're able to kind of shrink everything down in that sort of interdigital space. So you don't actually extend outside past the edge of the finger.
Okay.
So, and it hasn't failed. The only time it's ever failed was when I didn't bother to melt it into the plastic, and it will pull through if you don't melt it in. But once it's melted in, it seems to hold just fine. We haven't had any problems.
Okay. We've actually started, like my fingers they're snap pin, but they're also ABS cemented in place.
Oh, okay.
So there's no way they could fall out.
Yeah.
We've completely stopped using Chicago screws.
Yeah.
Because I'll put one in, and then not 24 hours later, I'm starting to lose ends.
Yeah. You need to Loctite those if you want them to hold up.
Yeah.
I'll take a moment to welcome Jeff aboard.
Hey, how's it going?
Hey, Jeff.
Not too bad.
Yeah. Actually, I mean, it's sort of an earlier topic, but I wanted to. we were talking about the dog bones on the flexi hand, and there was talk about the durability of using urethanes, to kind of doing a mold and using urethanes, and there's talk of using silicones as well. So there's a very commonly used component in in orthotics. It's called the Tamarack ankle joint. And I can send you guys a link to it. But essentially, it is a urethane dog bone, but it has Kevlar wire that wraps around two kind of brass, essentially Chicago nuts on either side of the dog bone, and that's sort of been wrapped around there before they did the mold with the urethane, so that Kevlar in that case just gets embedded in the urethane, and prevents any elongation of the urethane. So it holds up a lot longer, a lot stronger. Oh, can you hear me?
Yeah.
Yeah.
Okay.
Sorry, I'm looking at the video or the pictures of that ankle joint.
Oh, good.
Did you share a link?
Yeah.
Do you see where the group chat is on this?
Yeah. I'll copy it in.
Here.
Okay. Oh, not the group chat. There's actually one in the Hangout itself.
On the left-hand side at the very top if you click that icon, it opens up a group chat on the right-hand side.
Whoa. Okay, so this is all new to me, so you gotta.
That's all right.
Sorry.
Okay, so okay, there we go.
Oh, here we go. Sorry, wrong link.
I should put something in there. Okay,
Yeah.
so I see what Adam just put in. Oh, hey, what did I do?
Yeah, Adam posted it right. I posted it wrong.
Yep. Oh, good. Yeah, now that homepage actually does have a decent picture of what they did inside there.
Yeah, that's interesting. I hadn't seen those before. Those are orthotic supports?
Yeah. I didn't lose you. I just clicked away.
No, you're still there.
Okay. Yeah, so those are used for like AFOs, which is ankle foot orthosis.
Yeah.
Very frequently used at the ankle.
Huh. Yeah, we hadn't used those. We used the those prefab that kind of cut to shape. Not urethane, whatever that plastic is, and then we use the carbon fibers. But I hadn't seen these. These are interesting.
Yeah.
So I'm sharing your link now. I'm sharing my screen.
Okay. I'm going to make you presenter for a moment.
So is that the one, Jeff?
We use the prefab that kind of cut to shape. Not urethane, whatever that plastic is, and then we use the carbon
Oh, there's an
fibers.
echo.
That's. Are you still watching the video in another window, Jeff?
No.
So I'm sharing your link now. I'm sharing my screen. Somebody is.
Yeah, somebody's watching it because there's a couple minute delay and there's an echo.
Oh, that might have been me.
It's easy to do. We've all done it.
Yeah. There's a lot of gotchas with this. I mean, anytime trying to use Hangouts, there's all kinds of ways that it'll get you.
Okay, so I think am I good?
Yeah.
It's fine. You're totally fine.
Okay. Yeah, this is the whole Google Plus thing's new to me, and this is first time I've been on a group hangout. So bear with me, please. Sorry.
No worries.
Yeah, you're totally fine, Jeff. If you want to, you can add me to your circles, and I can walk you through all kinds of stuff on Google Plus anytime you want.
Ooh, I'm going to take you up on that.
You are very welcome to. So anyway, Jeff, you see my screen?
Yes.
Is this what you were talking about?
Yes, that's totally what I was talking about. So I guess my point is that we could make that using kind of a negative mold, and then just sort of you could use Chicago screws or something else that kind of be those two terminals that you wrap the you could just use a nylon thread of some sort, wrap around and then pour your injection mold, and it would just greatly increase the durability that Nick was expressing concern with earlier.
Right.
Has anybody heard of a long duration wear of a FlexiHand or any component that uses the Ninja Flex or Filaflex?
I think Steve might have some data on that. It might be worth actually asking him.
So when I asked him, he gave me data on basically a passive flexion test. So basically they had a machine that just bent it like this over and over, but it was an unloaded scenario. So okay. I don't know what it is in kind of a real ADL kind of environment. We fit one to a patient in Syria, and the gauntlet broke at a week. So we didn't get any information on the flexible component. But
right.
Yeah. Well, but the flexors just do extension, so there shouldn't be any load on them.
Yeah, except that once you're pulling that string, so they're still trying to shear themselves apart, right? Because they provide play within the scope of what the string can control.
Right.
So
okay.
I don't know. I mean, they may be fine. I really don't know.
It's also the dog bones are also holding the joint together. They're not just to extend the finger. They're also structural.
Holding each digit.
Yeah.
And
so
that's why
the string is kind of holding it, but that's I mean, everything is trying to shear itself apart at the same time. So
yeah, since there's no hinge or pin in those.
Right. Sorry, Lydia, you had a question?
Oh, no, I was waiting for a chance to change the subject, so keep going until you're ready to change the subject.
Oh.
Well, I'll probably do a mold test one of these days, with kind of that type of film, and, give you some insights.
Okay.
So now's good.
Let's see.
Okay.
Yeah, go ahead.
So, Adam, can you talk more about your Altoid tin repair?
Yeah, so my concern is that right now we don't really, to the best of my knowledge, we don't have a lot of data. I still haven't seen anything come out of Creighton. They probably have the best, if any, data exists. But, Peregrine's definitely the heaviest user. But basically, what kind of survival specific components have, how often they break. So for an austere environment, basically the goal was to be able to equip someone to be able to single-handedly repair these things. And I mean literally single-handedly, not just figuratively. So the idea was to design everything around being one-hand repair, tool-free was kind of the goal. So basically, how many tools can you get away from? And if you can get away from all of them, great. And then basically work under the assumption that we can make the gauntlet and break. I don't know what the right terms are. I refer to this as the bracer with my students because that's what it is in armory. But the bracer and then the actual, what I call the gauntlet, which is the glove part. Basically assume that we can make those strong enough, but the fingers, there's no way you're going to be able to make them strong enough. I mean, if you look at what commercial prosthetics are, those are machined aluminum or machined steel or machined titanium components, so they're going to break. So you just got to make them replaceable in a low maintenance environment. So the idea was you print a hand plus, what we were thinking is basically you print a hand plus, say, 3 extra fingers. All the fingers are standardized. It's pre-threaded, so all you got to do is, and you could do the same thing with the push-pull that Peregrine's got there. You pre-thread the filament through it. You just thread that through. You crimp it down, and you're able to go on your way instead of having to kind of. What I don't like about the current hand design is you've got to pull that pin out. You basically have got to disassemble all the fingers in order to replace one finger, and so that was one thing we were trying to get away from a little bit. It doesn't look as bad as I thought it was watching Peregrine do it because I just watched him do it, but I did want to get away from that too. So the idea is field maintainable. That's kind of where we're going for.
Mm-hmm.
Yeah.
Okay, and sorry.
Oh, I was just going to point out that when the fingers break, it is always right there.
Right.
Every single time.
Right.
Without fail. So what we did was just make that part really bulky so they don't break anymore.
Right.
So
when we designed these fingers, one of the analyses we did was by although they are not as bulky, by having the open channel, what you're doing is you're creating sort of a compliant link. So it's not trying to be perfectly strong. It gives some. And so at least mathematically, and engineers love math, but at least mathematically it should be able to handle certain loads that you otherwise can't, basically. That may or may not happen, but basically you're sort of putting a spring component in there to alleviate those loads rather than trying to be perfectly strong. I don't know if it'll work or not, but that's what we're going for.
Well, what happened was that we bulked this up enough, and then the next thing to break was actually down here.
Yeah, it's that one-horse shay thing. Like, you make this part strong enough so that it, this is strong and then that's strong. You just keep chasing your tail until you define what your life goal is, right? And
until I can no longer break it.
Right.
I
mean, I think it is inconceivable that we will design something that is not breakable. I mean, I think Jeff will comment on the ability of capable patients to break anything. So it's gonna break. What you've got to be able to do is make it maintainable for someone in an austere environment, or even in a non-austere environment, right?
True. Very true.
So, I mean, I've seen people come in with those Hosmer hooks broken, and I mean, those things are pretty strong. And, you know, you use it, I mean, the stronger you make it, the more inclined people are to use it as tools, I think. And so they become hammers, screwdrivers, wrenches, and, you know, I don't know, maybe they were splitting firewood with it. I don't know. But
I had a recent patient who wanted a hammer, so I put a stainless steel plate right here. And so, you know, he set the, you know, he set a nail, smack it, and
Nice.
then, you know, and then pick up a hammer and finish. You know, but that was how he set his nails. So,
that's awesome.
Yeah.
so
I like to set the
before
nail
we
with
did
the
that,
hand, because then I can hit it as hard as I want.
Mhm.
Put a magnet behind it, and you don't even have to set the nail up.
yeah. Sure.
So, Lydia, to answer your second question on the friction welding, we're not doing friction welding. We use a soldering iron. I've also just taken a 10-penny nail and heated it over the stove and used that for melting the filament.
Well, what I'm saying is, are you saying that the 10-penny nail over over a fire even would be what they would be able to do in an austere environment?
Oh, yeah. I mean, the original fabrication is not likely to happen in a hyper-austere environment, right? You've got a 3D printer. You know, it's, you know. So the idea is when you provide the finger, you've already got all the hinges welded in place, right? That doesn't
I'm talking about repairs.
Yeah, so you shouldn't have to, so the finger becomes a consumable item. If the finger breaks, you throw away the whole finger, right? You don't replace just the tip of the finger. What you do is you give someone 5 extra fingers that are intact entities that they're able to just quickly snap off and snap back on. That's it. So you just sort of, it doesn't matter how the finger breaks, the whole finger gets replaced at once.
Well, my thinking is that, yeah, so you give them 5 extra fingers. Are you saying 5 extra fingers for each finger? Because
no, all the fingers are the same geometry, so that's a little bit different here.
yeah,
So,
what I'm getting at is over a lifetime, people can go through fingers really fast, especially.
oh yeah, so
like that.
no, I mean, there is, with any patient, you're expecting to see them back with some periodicity. So this isn't, this is not a fire and forget kind of thing. So the idea is you give them enough that they can go, hopefully, without you for 6 months or a year or something like that. How long that is depends on the patient and depends on the design. But, you know, the idea is, I don't know, how often do you break fingers, Peregrine, at this point?
At this point, I have yet to break any of the fingers we've made. The original snap together RoboHand fingers, I was breaking. I broke 6 fingers in the first 5 weeks.
Okay.
So it's come a long way. But keep in mind, I broke one of those because I was.
You were using it as a hammer, weren't you?
No, not a hammer. I was up in Washington. The blackberry bushes are a big problem. Big enough that you can stand inside them.
Yeah.
I was in fact standing in one such with I think the vine was about that big around, holding it in this hand. Then I had a katana in the other hand, and I went like that to cut it. And I'd been using it for a little too long, and the blade was kind of dull, and I snapped the middle finger back.
You're lucky that's all you did.
Yeah, well, it's like it just kind of kept on going.
Just get a goat. That's the way I thought that was how we solved it up here. Anyway,
it would have eaten the goat. It was trying to eat the house.
Anyway, but yeah, that's basically the idea, is that you create a design, you expect it to fail, but you give the ability to repair, and you kind of scope out a 6-month or a year, intermittent checkpoint. I mean, yeah, you could equip them with 100, but there's no way that the rest of the system genuinely is going to last that long. Also, given the overall strategic goal of e-NABLE tends towards the pediatric side, they're changing size. Patient expectations change over time, so I would expect to see them. What I want to be able to do, though, is that they're able to self-maintain for a period of time. That seems like a reasonable goal. I have no expectation that we can make this thing bulletproof. It's not gonna be. It's plastic.
Yeah. Yeah, if you're going to do that, you need to get at least into aluminum.
Right.
But it sounds like people figure out how to destroy even that.
Yeah, it's like football. You put more pads on them, they just start hitting harder, right? So, to me, it's about establishing, managing expectations, and providing people the tools to make themselves able to do the repairs, do the maintenance. I don't know. I don't really know where the end point is. I don't know what a reasonable end expectation is. Peregrine is our N of 1. So, I don't know of anybody that uses it like you do. So.
Yeah, I'm seeing my end game as an indestructible hand, but that's also because my end game involves contracting some people out to, cast this in some kind of aluminum alloy.
Well, and one of the other challenges that you face is you are very tolerant to the geometry presented by the RoboHand, the Raptor, that kind of stuff. It's kind of a big beast.
Oh yeah.
A lot of patients, they're not interested, right? You present something that looks like that, kids think it's cool. I don't know even how long the kids think it's cool. I don't know when they start to wear out on it. But at some, particularly what we're seeing for the adult patients, and it's consistent with what we saw before, at the end of the day, they want something that looks like their hand. And so to make it strong enough is going to be challenging within that form factor.
Okay.
So it's a different problem though, right?
Yeah.
And this is one of the things where I'm looking at what hand do you want? Do you want something, and this is the same problem prosthetists face, right? Do you want, Jeff can talk about this, I've seen people do these amazingly, I remember I was at a conference, and a buddy of mine, he was an Iraq War veteran, and he was a transradial amputee, and he was sitting there, and he was just absent-mindedly playing with his pencil, and he has a body-powered shoulder harness Hosmer hook, and he's just sitting there just kind of twiddling around with it. But to him, it's become so second nature to use it that way that he's totally fine with it. He has no desire in a cosmetic hand because he's like, hey, this is me, suck it up. He's also, he's a Marine captain, and so he probably came in with that attitude, Okay. The people that we work with in Syria, and actually many of the patients I worked with when I was in industry, they are much more sensitive to social perception.
Okay.
That's gotten to be a lot less in the United States, but internationally, social perception still dominates. People would rather have nothing on their hand and have it in their pocket so you can't tell that they look different than have the additional functionality but look weird.
Yes.
And they define weird in a very... Right, exactly. And so, there's a reason there's a lot of different upper extremity prostheses on the market. It's because some people are totally cool with a Greifer hand. I don't even know if I call it a hand, a Greifer terminal device. And some people are cool with the Hosmer body powered, and some people want the full bore, eye-limb, even though it breaks every day. So I don't know. Maybe that's not been your. Have you fit any eye-limbs, Jeff?
Yeah, I have.
And B-Bionics? What's been your experience? We saw them back about once a month.
What's that?
We were seeing them back about once a month.
Yikes.
Yeah. What was going for them?
Everything. Now, this was early on with B-Bionic. We were burning out boards, and we were breaking fingers. They tend to break fingers. Same problem we have, honestly.
Yeah. The Touch Bionic got better about their finger strength. And when I'm using boards, I was just using relatively simple boards. I was just using Autobot because it's pretty as bomb-proof as the boards get.
Yeah.
But I was gonna ask you earlier. I mean, when you get to a stable design for the fingers, have you thought about trying to get them like injection molded in Delron or something like that?
I'm more interested in being able to. So personally, this is just me. The groups that I'm working with are the challenge is logistics. So when you're working with a refugee type scenario, you want to be able to meet the need as it arrives. And when you're looking at injection molded components, you got to say, okay, 3 months from now, I'm going to have this many amputees.
Right.
And so when the original conversation started with the guy I'm working with in Jordan, in Syria, they were asking, can you 3D print cane handles? Like, cane handles? That's a ridiculous idea, but they have to 3 months out between procurement, purchasing, fundraising, if that's required, customs, all that sort of stuff. It is a multi-month lead time to get this stuff done. And so if you can solve that problem if all I've got to do is say, hey, I need 50 spools of nylon XT or of whatever, and I can make whatever I need, that's the need that I'm kind of hitting on, I guess. So it's a different scenario.
That's fascinating.
If you want in, I'm sure they would be glad to have some advice from someone who actually knows prosthetics, Jeff, by the way. So.
Send me a link. I'd be happy to talk.
Okay. I'll hook you in.
Yeah.
And while we've got a pause, welcoming Nicholas Hall to the conversation.
I think
he doesn't unmute us.
Oh.
I'm not sure if you guys know, but Nick actually was up in my lab yesterday.
Really?
Yeah. So John, Skip, and Nick came to visit me over the weekend.
That's cool.
Yeah, we did some planning. So we actually the thing that still is blowing my mind was and I played with it all day today, like in between patients, was so Skip came with what he called PLA plywood, which was essentially just layered and layered PLA in kind of a grid pattern. And then he kind of took that and shaped it into a gauntlet or a tensor for Adam, into that shape. Kind of, he heated it up into with some boiling water, and then kind of formed it into a rounded shape, a flat sheet. And that worked very well, and it was very strong. So then we got kind of some other ideas. We're like, well, what if we do this? What if we could do this? So I have a big oven, so I was like, okay, let's throw it in the oven and then kind of reshape it. Well, we throw it in the oven and forget about it. Start talking about other things. The thing kind of essentially melts in the oven. Pull it out, like, oh, bummer. Well, so then pull that out, and it's like, well, since we got this blob of stuff, let's just play with it. Kind of pull it out and put it onto a mold, and just did a really complicated three-dimensional shape out of that blob, and then found that it was incredibly strong. Like, I'm still blown away for something with that low of a melting temperature, how strong of a plastic is. I work with a lot of different plastics. It's just, I think it was a combination of fiber direction that is created by the layers and layers of the PLA, but then by heating it in the oven, bonding those layers together very well, and then by slowly cooling them, we didn't temper it when we cooled it, so it annealed well. Like it was one of the cooler plastics I've ever played with. So
I don't have a vision. I don't have a vision of what that plywood thing looks like. Is there a picture anywhere of what those layers interacting look like?
So pre-blob or post-blob?
Either.
What's that?
I think once it's melted, probably it's hard to tell, but
yeah, you can't see any layers.
Yeah.
So what it was 4 layers high of just a standard, if you were just going to print a rectangle 2 millimeters high, it was just 4 layers of PLA on diagonals so one diagonal all the way across, and then 90 or perpendicular to that, the next diagonal, 4 layers high. It didn't look like anything. Skip stuck it in boiling water just to form it initially into a gauntlet, and then after it was nothing special, but it was still pretty strong just from boiling water. But after we put it in the oven, I've never seen anything like it. I mean, we did some carbon fiber, a relatively inexpensive thermoset carbon fiber, but like kidding, it was stronger than the carbon fiber. Like when you put a lot of pressure on the carbon fiber or on a tight bend, it cracked. This stuff, I tried to bend it. I'm a big, strong guy. I used both hands and tried to bend it as hard as I could, and I couldn't do it. Like it hurt my hands before it didn't even flex. It's the strongest thing that I've ever played with.
Yeah, PLA is very nearly as strong as ABS. The interlaminar, the weakness in any of this stuff is the interlaminar bonding from the deposition. Right. So by that heat annealing, you're taking care of that. It is a good plastic. They've got great material properties. And being able to work it, the problem is if you're working in the American Southwest or anywhere there's desert and it gets stinking hot, PLA is useless. But for those of you in New York, that's irrelevant. So.
Yeah, I was playing with that today actually. I was finding that from about 160 degrees, anything over 160 degrees, it would lose all shape. But it was 170. At about 170, I could de-shape it, reposition it, but then I would have a memory and would go back. So below that, and then once you got down to like 150 or so, you couldn't really do anything. It was a rigid structure that you couldn't really flex.
The comment I got was left in a hot car in Jordan, your spool of material turns into a blob. Yeah. So I don't know how hot that is. I would think maybe 130 degrees, but maybe it's the duration. I don't know. But they said it basically kind of fuses itself together. Your fine tolerances kind of go away. So there was say what?
I think that out there you can get 130 degrees outside.
Yeah, I think you're above 130 in that car.
Maybe that's it. I don't know.
130 is the kind of stuff you can get in a car here, but I get the impression that things are a lot hotter out there.
Yeah, that could be. It was just for our particular purposes. We have chosen not to use PLA. We're looking at ABS and nylon XT. So.
I'm actually in the Southwest, and yeah, it can get really hot inside the car. I've gotten into the habit of turning on the air conditioner with the doors open to blow all the air out before closing the door and start driving. It get hot enough that your CDs will melt on the dashboard.
So, all right, folks. I think I'm gonna bug out. It's been longer than I expected anyway. I gotta go make dinner. So,
thanks for joining us.
I will see you. Thanks. Fun conversation. And nice to actually see you, Jeff. I've received emails from you, but it's cool.
Yeah. We're good to do.
Yeah. All right. It's good seeing everybody. Thanks.
All right.
Bye, Adam.
Bye.
Hey, Adam.
Hi, Nicholas.
Hello. Good to see you.
I'm going to walk away from the computer for just a second. I got to grab another soda.
But just to hit a point on the PLA. So I mean, there's the one thing, yeah. I mean, if you're in Jordan and you're leaving it in a car, it's not going to end well. I think we'll all concede that point. But the reality is, I would guess that probably 80% or more of all components that are being built today are probably being built out of PLA anyhow. So the question isn't necessarily what's the ideal filament to use. The question is, given that the vast majority of people are using PLA, what's the best way to use it? That's how I'm looking at this. And there's no question that nylon is superior to PLA, but if you're going to use PLA, this is an interesting way to use it. It's a lot stronger. I mean, a standard gauntlet is we usually make it. I mean, I can take it, even a good print, I can take it in one hand and I can crush it. And this is 10x, at least 10 times as strong as anything I've ever printed. Straight out printer.
That's pre-blob. Just the the stuff that Skip brought. We both grabbed it and tried to squeeze it as hard as we could. We could get the two ends of the gauntlet to touch each other with no breakage. It would just go. You could just go back to shape.
Which definitely does not happen with a printed gauntlet. So I think it's interesting. It'll be interesting to experiment with. One of the things that I'm interested in seeing is if blanching as a post-processing method would be useful. So essentially, what I mean is, Skip achieved tremendous strength just from putting it in hot water. It may be possible to print a part and just dip it in boiling water. Like a printed gauntlet as you ordinarily would, as it's ordinarily configured, and just dip it in boiling water for 10 seconds, just to get the outer shell, your outer layers, to actually fuse much more effectively than they typically do on a standard print. I don't know if that'll work or not, but I think it'd be interesting to try, and cheap enough to try, to see if you can get any additional strength that way.
We've had some effect with that. This is actually an ABS hand.
Okay.
We use the acetone to smooth it out, and that fuses the outer layers. And I think it's a bit stronger. We haven't broken as much since we've started doing that.
And that's exactly the way I'm thinking of it is, like you say with ABS, like the acetone finish. Everyone says it makes it stronger. I've never seen data that says how much stronger, but everything I've ever seen on the internet says doing that acetone bath makes a big difference.
Well,
and with PLA, you can't do that without some pretty toxic stuff. A simple dip in boiling water for 10 seconds might be enough, a cheap, safe, effective way to accomplish the same thing with PLA.
We've actually been reluctant to use PLA very much because we don't have anything that will that smooths it off the same way.
Right.
But also, it also makes the parts move a lot more smoothly.
Oh, that's interesting.
Well, because you have all those lines from laying out the filament, those create a lot of friction.
Right, that makes sense.
We smooth it off, and this is probably the quietest and smoothest action hand I have.
Yeah, it was a pleasure watching that video. That was pretty cool. It's amazing how the Bowden cable trimmer line. That's some really cool stuff. I was pretty impressed.
Right. Yeah. Well, the funny thing is that this hand wasn't actually. We did not design it to use Bowden push-pull cables.
Right.
That was when I was switching out the old. Yeah, that's when I was switching out the old elastics and didn't put them back in.
It looks like it works, so that's cool.
Hey, Perrin, have you tried putting anything else on the palm other than the leather?
On this hand, no. I've got a Cyborg Beast and 2 Raptors upstairs that have the Velcro on them.
Have you tried anything else other than just the Velcro and the leather?
I have not, no. It's only been leather and Velcro straps.
Yeah, I was watching the video and I saw, when you were picking up the glass of water, and wanted to slip around a little bit. And it was just something that had a little bit more, texture or grip, in that palm would probably help a lot.
Like silicone?
Yeah, silicone.
Yeah, but a silicone pad there could help.
We saw, I think it was Aaron Brown that was doing the silicone-infused sheets of basically T-shirt material. And was
that was actually me.
I remember, yeah.
Well,
You made a bunch of. You made some hand that had a whole bunch of like silicone stuff in it, with some really impressive gripping ability.
Yeah. I found that putting silicone in the palm, a textured silicone on the palm, really improves how well it grips. And it's something I'd like to play around with a lot more, just to see how much more grip you can get out of the same hand just by just getting more friction in there. I think that's something worth exploring for sure.
Yeah, I think the issue with that cup there was also that I'm still using the thumb to the side, that key grip, I guess. I think that's what that's called.
Yeah.
Which is not ideal for picking up a cylinder.
Well, another thing I think would make a big difference is there's the Skip meets Steve Wood's Whipple tree mechanism. I think folks have probably seen him using it in his Raptor adapter hand. It just looks like almost like a little. I can't think of the name of the shape, but it's just triangular, and basically it gives you an adaptive grip. And while I was with Jeff and Skip this weekend, I got to play around with it a little bit, and it's pretty impressive. So basically, like when you're picking up that glass, the first the thumb, index, and middle finger really mostly engaging it. But then once those stop, the other fingers have to stop too, because they can't go any further than the first finger that stops the rest of them. Whereas with Skip's mechanism, actually I think I have one in my pocket, as luck would have it.
I think I've seen that.
Yeah, this little thing right here.
Yeah.
This is amazingly effective. Your index finger can stop. Usually, your index finger gets to. There we go. You get to here, and then everything else has to stop. With his mechanism, the index finger can stop there, and you can do this. With the hand, you can anything you want to. You can put all the fingers can be in a different position. And in terms of gripping things, even a glass like you did, your pinky and your ring finger would also come into play and be able to get engaged with the glass as well, which is pretty cool. And this takes about, I don't know, that's like a 20-minute print. It's pretty quick.
Yeah.
Okay.
I'm getting like that.
I think you've got a little bit of elasticity in your cables too.
Yeah, well, it's not so much elasticity, so much as when the cables go around a sharp corner, they don't go around it at that sharp angle.
Yeah.
Okay.
And as you apply more pressure to it, the cables go around the cable. They go around that angle sharper and sharper.
That makes sense.
So some of the fingers have a lot of. Some of the fingers end up with a lot of pressure behind them, and others not so much because they could still go around that angle a little bit more closely. We've actually been trying to figure out ways to take out adaptability in the grip, because adaptability, so far, it seems you have to choose between that or strength.
It seems to do what?
So far, it seems that you have to choose between an adaptable grip or a strong grip.
Why do you say that?
In the sense that after if something is actively pulling against that grip, then sometimes if the grip is too adaptive, then things will adapt right out of the grip.
Yeah, so if the little finger is able to flex too far, the other fingers are going to loosen. So.
Yeah, is it?
At least with
if the fingers are allowed to move too much without, if the fingers can move without the wrist flexing, then that gives you less control over the fingers.
It could be.
Yeah.
That was one issue the really early hands I had, some of the cable was even. I was having issue with. I think it was actually the cable guide wasn't fixed down, so the cables had a lot more play in them, and I could wrap my fingers around a palm-sized sphere easily. But then if I tried to pull that sphere out of my hand, it would just fall out because the fingers would just kind of flex away from it.
Right.
Hey, Peregrine. I mean, it's not exactly R&D topic, but as a prosthetist, I'm learning from the community. Like, did you try a more conventional prosthesis at some point in time, or was that never really on your radar?
The only thing I tried before this was years and years ago. I had an opposition bar. It was just something strapped to my forearm that I could pin things against.
Yeah.
I used it for about a week before deciding it was more trouble than it was worth.
Got it.
That's when I was about like 7 or 8.
Okay.
And other than that, no.
Okay. Was that like at a Shriners or something, or?
I don't even
know if you do that, or.
I think we just had like. I don't actually know how we decided, like, when we did that, but I remember we had like. It was like some sort of brace and incense holder.
Cool.
It might have been his idea.
Nice.
That seems like the kind of thing he would have.
Yeah.
Was that your idea to do the opposition bar? With the brace and the incense holder?
Oh gosh. Maybe.
It seems like something you would have cooked up.
Yeah.
Now I got it. And I like it, but I can see how it would get in the way too.
Yeah, it was a cool idea, though it ended up getting in the way.
Yeah.
Yeah.
I tried to make a kid. I had a kid who, well, actually, he recently got a raptor, but when he was 5, he came in to see me. He wanted a hand for hockey, and so I made essentially a padded glove that he could use, and then I was like, and then talking to him, I was like, well, I'm going to try to make this thing, and essentially I made an opposition bar very similar to what you did, and so he could kind of do that for grabbing the hockey stick, and he hated it, and he just kind of stuck the tip of the stick in his armpit, and just sort of put his and he plays pretty well with it,
Yeah, that's what I did.
Yeah.
So,
Yeah, no, we had talked at length with Nick about this. I don't think there was a good option before the M fingers, for our field, and and then bioelectrics, but they're really not a good option for partial hands, anyways, except for one that's super expensive.
No, you have to fit machinery for fingers in the space that fingers take up, and that doesn't really work.
Doesn't work well.
We don't do that biologically.
Yeah.
So.
No, you got a good point. We don't do that biologically.
Take the whole forearm to do it.
Yep, you're right.
So. Yeah.
That was something I mentioned in the comments on this post, on the post of this event. I was curious what anybody thought about. Have you guys looked at the Adafruit has a similar to Arduino platform called Trinket that are like smaller than a thumb drive, smaller than a USB drive. They're about a little bit longer, or a little bit longer than a quarter, and a little bit narrower than a quarter. And they are programmable. 2 or 3 inputs, outputs. I think some of the inputs can be either input or output, so there's an overlap on how many of each there are. and the programming languages that it uses are similar. I think you can take programs for an Arduino and change the pin addresses and recompile it for the Trinket. But they're small enough that I was wondering if you guys had any ideas as to what uses you could see for these in our electronic, like the myoelectric and other types of equipment that we've been playing with.
I'm not involved in any of that.
Yeah.
Yeah. Do you have a link to one, like a picture of one?
Yeah. Hold on.
This is purely speculation because I'm not part of that group. Though I'd imagine anyway that the biggest issue would be fitting a battery on there. It's not so much the
Right. They are. I think that you could get just a normal lithium-ion battery, like a cell phone battery, and use that to power it. It looks like it allows a USB port for providing power, and the voltages are pretty small. They're like 3 volt and 5 volt.
Okay.
So, I mean, I just put a link in the sidebar.
Okay. Now, I don't know enough about motors to know if you could run a reasonably powerful grid
Right.
like that.
I'm not sure that you could. You would need to. You wouldn't run the power for the motor through the Trinket. You would use the Trinket to control a relay to run the power, or to control a transistor to run the power.
Okay.
Because the voltages are kind of lightweight for controlling a stepper.
Yeah.
But I'm thinking about inputs. I'm thinking about sensory feedback, and
I'm sure that having something that small would be useful, or at least more useful than something larger.
Right.
But it's all about, I think anyway. Again, I don't actually know what I'm talking about, but I think it's all about trying to just fit that much machinery into a small enough space.
Right. Yeah, these are. I mean, I just posted a link. You can see how small they are. These are small enough that you can easily fit them into the back of the palm.
Oh yeah.
And I'm thinking that, yeah, I mean, she's doing this with it in the picture, and it fits, like between, within these two joints, and it's, they're tiny. And I'm thinking if you could put some sensor in the fingertips, and then like pager motors spaced out on your palm or on your forearm or wrist, and so that when a finger touches, it causes one of the pager motors to vibrate or something similar. And I'm still just brainstorming. I discovered these last week, and I've been thinking a lot about them, and curious if you guys had any ideas on what you would use these for, and not necessarily for this discussion, but just I wanted to get the idea of these out so that people start thinking about them.
Mm-hmm. Oh, good.
Oh, there has been some work on biofeedback that similar to what you're describing. It's all kind of universities and places, and it hasn't made it out into the open market. So I more or less, I just have been waiting until someone else figures it out.
Right.
But it's intriguing. It's very intriguing.
Yeah. Yeah, and I mean they've got enough input-output, GPIO on these. There's 5 pins that can be either inputs or outputs, and I think some of them are dedicated output and some of them are dedicated input. And two of them can't be used while you are programming it with the USB port because they become USB data input lines while you're loading code onto it. But once you've loaded the code, they can be used like any other input or output. And I guess they can do PWM signals, which I think would be fun for playing around with like persistence of vision. I'd like to try using Trinket to control LEDs on the spokes of my bike, for example, to create images as the spokes are spinning.
I think you and Debbie Leung should talk to each other about it.
I think we should. She seems to dive into the same games that I like to play with electronics.
Yeah, and Shashi Jain actually works for Intel, and so you could talk to him about chips in general.
Right.
Cool.
That's all I had to bring up. I was just curious if you guys had any thoughts about it.
Nope.
You're above my pay grade.
Yeah. I suppose you were gonna try to do some not myoelectric, but any like go-go gadget style attachments.
Yeah.
That might be pretty useful.
Yeah, these would be good for I don't know, like for controlling lights or controlling lasers, or I'm not sure what else.
Yeah. Well, yesterday I saw a wrist-mounted fireball launcher that I've been eyeing.
Right.
So I'm sure you could figure out how to wire something like that up to.
Used to control ignition and
Launching.
yeah, for ignition and for whether or not to spray.
Yeah, I don't know. There's some definitely some interesting applications there if you want to get into the whole go-go gadget utility stuff.
I have a crying 2-year-old, so I'll say goodnight to you guys.
Thanks for joining us, Jeff.
Yeah,
Jeff.
good talking to you.
All
Good to see
right.
it.
Likewise.
Well, I think I may take off too. I'm just tired.
Sounds good.
Bye, everybody.
But
Bye.
yeah, I think it's my bedtime too.
I think it's not a bad time to start wrapping up anyway.
It sounds like it's time to wrap things up. It's
Good
been
checking with you guys.
2 hours now?
Yeah, it's about that. It's about how long these tend to run. We started at 1800, it's 20, so yeah. All right. Well, good to sit and chat with you again, Peregrine.
Likewise.
Good to talk to other people who actually have different styles of hands.
Yeah. All right. I gotta put this guy to bed.
Yeah, he looks like he's already asleep. My dad does that too.
Watch. Don't watch.